My name is Leo Jivanmal. I'll be your instructor. Welcome to MRI Basic Principles, Chapter 1, Part A. Our objectives for the following slides would be atoms, molecules, atomic structure, atomic mass, atomic number, hydrogen, and isotopes. Atoms are the building blocks of all matter. Everything we can see, feel, and touch is all made up of atoms. Even things we cannot see, feel, hear, or touch, they're also made up of atoms. Basically, everything around us is made up of atoms. For clinical purposes, MR imaging is based upon the generation of signal from atoms in human body or specimen. Everything, including human body, is made up of atoms. Most of these atoms may be found in two forms within the human specimen: as free water and body fluids, such as CSF, cerebral spinal fluid, also water-bound to large molecules such as proteins and lipids, and as hydrogen atoms with the fat molecules. A molecule, in essence, is a particle made up of two or more atoms. As you can see in water molecule, there are two hydrogen atoms that are bound together with the oxygen atom, and in different fats, saturated fat, you have the carbon atom with the hydrogen atoms. They are bounded together. We don't need to go in the depth of the chemical formation, but we need to know that molecules are particles that are made up of two or more atoms that are chemically bonded together. So in essence, anytime two atoms join together, they make up a molecule. Structure of atom. Atoms consist of a nucleus and a shell, which is made up of electrons. In nucleus, besides other things that are happening, for the sake of MRI, we'll just focus on two particles. The first one is electrically charged, positively electrically charged, I should say. These bodies are called protons. And then we have neutrally charged particles within the nucleus. They're called neutrons. So positive protons, neutrally charged neutrons. And then we have the electrons that are orbiting around the nucleus. Remember, neutrons and protons are within the nucleus. They're also referred to as nucleons. But outside the nucleus, we have these orbital bodies that are electrically charged, negatively charged. They're called electrons. So electrons are electrically charged, orbiting around the nucleus. Atomic mass and atomic number. The atomic nucleus is in the center, as we saw in this earlier slide. It's in the center of the atom. And the number of protons and neutrons in the atom define what type of atom or element it is. So a hydrogen atom we see right over here, the elemental symbol on the periodic table is H. So the protons and the neutrons that we talked about on this slide that reside in the nucleus, they basically tell us what kind of element it is, what kind of atom this is. In this example, we have hydrogen. So the definition of element is a bunch of atoms that all have the same type of atomic structure. For instance, hydrogen, in our example, is an element. So atomic number. The composition of the atomic nucleus gives us lots of information about the element it represents. The number of protons in an atom basically tell us the atomic number of the element. So in our case of hydrogen, we only have one proton, so we have an element and the atomic number is 1. Right over here is hydrogen, and we know the atomic number, because the number of protons is 1 in a hydrogen atom within the nucleus that it resides in. So we have 1. An atomic mass is number of protons plus neutrons. So you can see it's almost the same atomic mass and atomic number of hydrogen atom, or the element of hydrogen. This particular element has 1 mass and 1 atomic number. So by definition, the number of protons inside the nucleus gives us the atomic number. The atomic mass is the sum of the masses of all the protons and neutrons in an atom, or the average mass in a group of atoms. What about electrons? Electrons have so much less mass than protons and neutrons that they don't factor into the calculation. So that's why we're talking about the nucleons that we discussed right over here. The neutrons and protons, their masses added together give us the atomic mass number, and the atomic number is only the protons that are present in the nucleus. So hopefully that makes sense. If you have any questions, you can email me or ask me. If there are any confusions, I'll be more than happy to explain to you. So we're going to discuss about human body. Human body is basically 60% water. The reason we discuss so much about water and hydrogen is because that's the element that we'll be utilizing in clinical imaging for MR purposes. And the most abundant in our bodies is hydrogen because of water. And water molecule has 2 hydrogen atoms, as we saw in our earlier example. It has 2 hydrogen atoms that are bonded together with 1 oxygen atom. So hydrogen's solitary proton gives it a relatively large atomic or large magnetic moment. We'll discuss magnetic moments in the future slides, but for right now, MR imaging relies upon the spinning motion of specific nuclei present in biological tissues, and the hydrogen is perfect for MR imaging for that purpose. Hydrogen is also we know that hydrogen is one of the most abundant element found in human body, because 60% of human body is water, and we know that hydrogen is attached with the oxygen. 2 hydrogen atoms are attached with 1 oxygen and make up the water molecule. We're going to look at isotopes. What is an isotope? Atoms with the same number of protons but that have a different number of neutrons. Such as an example over here. They have the same number of protons but different number of neutrons. They will give us an element known as isotope. So atomic number, we know that is the number of protons. Atomic mass is the number of protons and number of neutrons. The same atomic number but different mass number would give us an isotope. So in a given element, the number of neutrons can be different from each other, while the number of protons is not. These different versions of the same element are called isotope. So we'll see our example right here. We have the hydrogen atom. The 3 are all isotopes of hydrogen. We have protium, we have deuterium, we have tritium. Excuse my pronunciation. We will be using protium in MRI, but as you can see, they have the same atomic number. Atomic number is the same, 1 right here and 1 atomic number, but they have a different atomic mass because they have different number of neutrons. There's 3 neutrons over here, and then there's 2 neutrons here, right? So the number of neutrons can be calculated by calculating the difference between the atomic mass and atomic number. So 3 minus 1, 2. 2 minus 1, 1. There's number of neutron. This is it right here. 1 minus 1, 0 neutrons. Right? Okay. So we can see that for the isotopes of hydrogen, they have varying number of neutrons. For protium, the number of neutrons is 0. For deuterium, the number of neutron is 1. And for tritium, the number of neutron is 2. The isotope of hydrogen called protium is the most commonly used MR active nucleus in MRI. It has a mass and atomic number of 1. So the nucleus consists of a single proton and has no neutrons. It is used because hydrogen is very abundant, again, in the human body, and because the solitary proton gives it a relatively large magnetic moment.